Earth 2.0 proposed space mission sets eyes on finding alternatives to Earth. China wants to find the first viable alternative to Earth in an upcoming hunt for exoplanets. With hopes of finding Earth 2.0, Chinese scientists are planning to survey planets outside our solar system in the Milky Way galaxy. If a planet like Earth is found orbiting a star, like our Sun, in a habitable zone, it means that humanity might actually have a shot at becoming an interstellar species. What would the planet need? The right conditions for liquid water and a result for life to exist. So far, humans have found 5,000 exoplanets in the Milky Way, especially with help from NASA's Kepler telescope that is now defunct. While some planets of these 5,000 did have Earth-like characteristics, none of them truly fit the definition of an Earth 2.0. China could soon begin its first space-based hunt for exoplanets, if a proposal from the Shanghai Astronomical Observatory gets the go-ahead this summer. The Earth 2.0 telescope would spend 4 years orbiting Sun-Earth Lagrange Point 2, about 930,000 miles from Earth. There, it would fix its 7 telescopes on a portion of the sky toward the galactic center and watch for signs of dimming as planets transit, or pass in front of, a star as they orbit. The main targets are roughly Earth-size exoplanets with similar orbits around Sun-like stars. This requires high sensitivity to spot the signals of small planet transits, as well as long-term monitoring to glimpse planets that take an earthly year to go around their star. The Chinese mission, called Earth 2.0, hopes to change that. It will be funded by the Chinese Academy of Sciences and is wrapping up its early design phase. If the designs pass a review by a panel of experts in June, the mission team will receive funding to start building the satellite. The team plans to launch the spacecraft on a Long March rocket before the end of 2026. Earth 2.0 mission is 10 times more powerful than Kepler. According to Scientific American, the Chinese mission is actually called Earth 2.0 and is funded by the Chinese Academy of Sciences. If its designs pass a review in June, the team will begin building a spacecraft that could be launched by 2026. This satellite will have 7 telescopes that will observe the sky for 4 years. The telescopes will look for exoplanets by finding small changes in a star's brightness, implying that a planet had passed in front of it. Earth 2.0 telescopes will be looking at 1.2 million stars spread across a 500 square degree patch of sky, about 5 times wider than Kepler's view. In addition, it will be able to observe stars that are dimmer and farther off. According to Zheng Jie, the astronomer behind the Earth 2.0 mission at the Shanghai Astronomical Observatory of the Chinese Academy of Sciences, the satellite could be 10 to 15 times more powerful than NASA's Kepler telescope. The Earth 2.0 satellite is designed to carry 7 telescopes that will observe the sky for 4 years. 6 of the telescopes will work together to survey the Cygnus Lyra constellations, the same patch of sky that the Kepler telescope scoured.
The Kepler field is a low-hanging fruit because we have very good data from there.
Said by Zheng Jie, the astronomer leading the Earth 2.0 mission at the Shanghai Astronomical Observatory of the Chinese Academy of Sciences. The telescopes will look for exoplanets by detecting small changes in a star's brightness that indicate that a planet has passed in front of it. Using multiple small telescopes together gives scientists a wider field of view than a single large telescope such as Kepler. Earth 2.0 have 6 telescopes will together stare at about 1.2 million stars across a 500 square degree patch of sky, which is about 5 times wider than Kepler's view was. At the same time, Earth 2.0 will be able to observe dimmer and more distant stars than does NASA's Transiting Exoplanet Survey satellite, which surveys bright stars near Earth. The satellite's 7th instrument will be a gravitational microlensing telescope for surveying rogue planets, free-roaming celestial objects that don't orbit any star, and exoplanets that are far from their star similar to Neptune. It will detect changes in starlight when the gravity of a planet or star warps the light of a background star that it is passing in front of. The telescope will target the center of the Milky Way where massive numbers of stars are located. If successfully launched, This would be the first gravitational microlensing telescope that operates from space. To discover if a planet is Earth-like and might be habitable or even inhabited, we will have to wait until we can probe the atmosphere or maybe even properties of the surface. The Earth 2.0 proposal is part of a Chinese Academy of Sciences space science satellite program. Other mission proposals are competing for funding in areas such as astronomy and space science, solar and space physics, planetary science, and Earth observation. Decisions on funding are expected in June. If the Earth 2.0 telescope mission is selected, the team will begin readying the satellite for a 2026 launch. Another exoplanet proposal, which seeks to find exoplanets by measuring how a star wobbles around the center of mass of the system due to the influence of planets' gravity, is also in the running. How good Earth 2.0 with Kepler? NASA launched Kepler in 2009, aiming to find out how common Earth-like planets are in the galaxy. To confirm that an exoplanet is Earth-like, astronomers need to measure the time it takes to orbit its sun. Such planets should have an orbital period similar to Earth's and transit their suns about once a year. Chelsea Huang, an astrophysicist at the University of Southern Queensland in Toowoomba, he added that scientists need at least 3 transits to work out a precise orbital period, which takes about 3 years of data and sometimes more if there are data gaps.
But 4 years into the Kepler mission, parts of the instrument failed, rendering the telescope unable to stare at one patch of the sky over an extended period of time. Kepler was on the cusp of finding some truly Earth-like planets.
Said by Huang, who has worked with the Earth 2.0 team as a data simulation consultant. With Earth 2.0, astronomers could have another 4 years of data that, when combined with Kepler's observations, could help to confirm which exoplanets are truly Earth-like. Christensen said that,
I am very excited about the prospect of returning to the Kepler field, who hopes to study Earth 2.0 data if they are made available.
G hopes to find a dozen Earth 2.0 planets. He says he plans to publish the data within 1 or 2 years of their collection. There will be a lot of data, so we need all the hands we can get. The team already has about 300 scientists and engineers, mostly from China, but G hopes more astronomers worldwide will join. Earth 2.0 is an opportunity for better international collaboration. The European Space Agency is also planning an exoplanet mission, called Planetary Transits and Oscillations of Stars, that is scheduled to launch in 2026. Plato's design has 26 telescopes, meaning that it will have a much larger field of view than Earth 2.0. But the satellite will shift its gaze every 2 years to observe different regions of the sky. The discovery of the first Earth 2.0 is likely to be one of the defining moments in the history of astronomy. It is likely to create huge interest in the nature of these planets, the makeup of their atmospheres, and the potential presence of water. Then there will be the search for biomarkers suggesting the presence of life, molecules like methane and oxygen, and the characteristic light absorption patterns of photosynthesis. Beyond that will be the search for technosignatures that might indicate the presence of a civilization. Signals such as industrial pollutants like chlorofluorocarbons and even narrowband radio transmissions. That's all about in this video. If you like the information, then please hit like and subscribe to this channel, and be connected for more space universe information.